Hey there, how's going? Welcome to CodeBuddy. Welcome to this tutorial video, and it is the third part of the mega series in programming in core Java 0 to Hero. Those who are following along with me in this series, a big thank you for making it to here. And to those who have joined in this video to learn this much only, also deserves a thank you for choosing CodeBuddy. So that being said, let's get started. So in the last video of this series, we have learned about variables and data types, and we have also worked on in-depth analysis of the code that we have worked in the first program. Also, by the end of the last video, you were able to write your very own Java program. If you haven't watched that yet, I would request you to do that if you need the above mentioned topics to be cleared. So in this video, we will be focusing on typecasting using various kind of operators and operands. So that being said, let's get started. So the first topic that we are going to discuss in this video is typecasting. It is a very handy operation when you are working with values. Now what is this typecasting? Typecasting is converting a particular data type into another. It has few limitations. Now let's see that in action. Suppose we have a variable named num and it is of integer type, and you store suppose 15 to it. Now what are we going to do? Suppose for the sake of a program, we need to convert this into a decimal point number. How can we do that? We simply typecast this number to either double or float. Let's see how can we do that. So suppose to typecast it in double format, we need to write double. Suppose I want to store it in a different number just to show you the difference. So it's new num, and then we start a parenthesis, and inside that we write double to the type which we want to typecast. Remember that this data type and this data type should be same, otherwise you will get an error. So then we want to typecast the num value, so we write num and then end it with a semicolon. After that, we want to print out the result on the screen. So to print out, we use system.out.println as we have already done. So first we'll see the integer, and for seeing the integer we write something like this, and we want to see num. After that, we want to see the typecasted value of this num into double data type. So for that we write double, and here the variable name is new num. Once that is done, we'll save this, and as we already know, the typecasting it into a particular data type changes the value to that particular data type. Now we know that double includes decimal points to it, so this 15 will be converted into 15.0, and it would have the same result if we would have converted into float. It would also result into 15.0. So let's see if that really works or not. So head over to our terminal, and from here we write javac test.java. Once it's compiled, we'll check the result using, and here we go. So integer is 15 because num was 15 and it was typecasted into double value. So after typecasted to double, 15 becomes 15.0. So I hope that really makes sense. So there are a few limitations of typecasting, as I have already mentioned in the start of this video. So the first limitation is that you cannot convert an integer into a string format. That doesn't happen in Java. So we want to see the error on the screen. So let's check it out. So we store it into a string data type, a variable name to string, and I want to typecast it into string. So we write string and then we use num. Okay, so that should work as far as the knowledge that we have of typecasting. So let's see what really comes out. This is a string and it is stored in a variable named to string. We save this and we want the result on the screen, right? So let's see the result. We compile this. Yeah, we get an error. And what error it shows? It shows incompatible types. Int cannot be converted to a string. So the Java error messages are quite clear sometimes, because it shows completely clear that int cannot be converted to a string, and that's what I mentioned earlier, that you cannot convert an int to a string. So in this fashion, you can typecast like an integer to a float or a double, or in fact, you can typecast a float to a double or a double to a float. Similarly. So this typecasting topic ends here. I hope that is clear to you now. It's a very handy topic. To know this is very useful, and in many part of a program, in many further end of a program, you will be needing typecasting. So that time it will really come handy. So the big topic of the video is operators. So the first question that comes in mind that what are operators? Now operators are tokens or symbols you can tell in Java that enhances your performance. It can be arithmetical performances, or it can be relational performances, or it can be logical performances. Sometimes operators are simply for assignment as well. Like the operator that we have already seen in these videos, that is equal sign. This equal to is an assignment operator which assigns the value to a particular variable. So in this fashion, there are many kind of operators. The most common and the useful ones are the unary operator, then we come the arithmetic operators, and then the relational operators, and then the logical operators. And finally, it's a conditional operator. We use this as ternary operator. So we'll start with unary operator. Now to explain unary operator, I want to take an example again. Okay, so suppose there is a variable named num and it has 15 to it. Now suppose I want to increase the value of 15 by 1. Now how can I do that? I have to write num equal to num plus 1, or we can write shorthand notations like this: num plus equals 1. This will also work fine. This is known as a shorthand operation of this operation. So these are the two ways by we can increase the value of num. Now where does this unary operator comes handy? Instead of using so many datas, we can simply type in num plus plus, and that would give the result on the screen as 16. So let's check it out. For the time being, let's remove this part. These are the conventional ways, but this is unary operator, and we want to print out the result on the screen. To print out the result, we use system.out.println, and this is unary operator. And to this, I want to print out num on the screen. So the result should be 16. Let's check it out. This is the last error. Okay, so we forgot a semicolon to it. Okay, my fault. Not an issue. Then again, we compile this and we should get a result now. It is Java test and the result is 16. So now you can understand that how unary operator works. Similarly, we could have written num minus minus. That would have given the result 14 on the screen. So this is the basic operations of unary operator. Now there comes a question that there are post increment and there is pre increment. Now what is this post increment and pre increment? Post increment works first and then increases the value. So this is an example of a post decrement. Why decrement? Because you are using minus minus after this. If it would have been plus plus, then it is a post increment operator. So a post increment operator, the value of num remains 15 at this line, and then it increases after this line is executed. So think it like this. So suppose the value here is 15, and suppose we want to perform a task of suppose it's a variable int sum equals 10 plus num plus plus. So this num plus plus will contain 15 in this line. So this line will have a result 10 plus 15 is 25, and then after this line is completed execution, then from the sixth line it will increase its value to 16. So let's see that in action for once. So we simply copy this line of printing and we want to see the result of sum. So let's see. Sum, hopefully we have completed all the semicolons and we want to see the result. Let's see. Compiled and see the result. So as I've already mentioned that this line contains value of num as 15 only, so that was 15 plus 10 is 25, and after this line is executed, its value is increased from the sixth line. So from sixth line this operation is already performed, so it does not get affected. So this is how post increment or decrement operator works. It would have been minus minus, then accordingly, like from this line it would have been 15, but after this line it would have been 14. Similarly, if you would have worked with pre, then it is decrement first or increment first and then the operation. So if we write here plus plus num, that means this line will increase num to 16 and then it will add it to 10, so it becomes 26 and sum's result will be 26. Okay, and similarly for minus minus, this is known as pre-decrement operator. It also decreases the value first and then performs this particular operation. So I hope you know the operators are very much clear now. So the next thing that we want to focus here is for arithmetical operations. The arithmetical operations are like simple mathematical operation. There is plus, there is minus, there is multiplication, there is division, and another thing that there is this thing. This is not percentage sign. This is known as modulus. So we'll see everything in action. So let's first create two variables. This is num1 is 10 and num2 is 52. And why I'm keeping 52? Because I want to see the remainder on the screen. Okay, after that the first operation we would be performing is sum. So in sum equals num1 plus num2. After that we want to perform subtraction, so it's diff equal to num1 minus num2. We want to perform multiplication, multi equal to num1 star num2. Then for division, in div equals num1. So suppose for this I want to keep is at num2 div num1. Why so? Because num2 is 52, so we want it 52 divided by 10. So this div operator gives the result of the quotient. So the result for this will be 5. Yes. And after that we'll perform div int mod equals num2 modulus num1, and this modulus operation returns the remainder. So this mod will contain the remainder, that is 2. So we'll see everything that in action. So we first write our printing statement, println, and we write sum plus is sum, and we'll simply copy this line for multiple times. The next is the difference, that is stored in diff. After that we have multiplication, so that is product, that is stored in a variable multi. Fine. After that we have division, normal division. This is like the quotient part, so it's stored in div. And finally we have the remainder, so we'll also keep this in a statement as remainder equals mod. So that will do, and hopefully we have closed all the semicolons, and let's see that in action again. So we compile this, no error. See the result. So it's 62. The difference is 52 minus 10 is 42. The product is 52 into 10 is 520, and the division returns the quotient part, so it is 5, and the remainder, as I've told, modulus returns the remainder part, so the modulus returns 2. So I think the operators, arithmetical operators, are very much clear now, and these are very handy, and in almost all the programs you will be working with, you have to use arithmetical operators. More than arithmetical operators, relational operators are very much useful, and also logical operations. So we will be seeing that in action next. Now comes relational operators. Now what are relational operators? Relational operators are used to check the relations between operands. And what are relations? Relations are like greater than, equals, less than, or less than equals, or sometimes it is double equals to check the equality between two numbers. And sometimes it is also not equals to check whether the numbers are not equal or not. So let's see few of them in action. So again, we'll do the same way that we create two variables, int num1 equal to 15 and int num2 equals 18. Fine. And now we want to print each and every result on the screen. So a relational operator always results in true or false, because if a number is greater than a particular number, what it will result? True. And if it is less, it will result false. So in this way, it really works. So let's see that in action and it will be very much clear. So num1 is greater than num2. Now, num1 is 15 and num2 is 18. So 15 is greater than 18? No, it's false. So this statement will return false on the screen. Similarly, let's check it out for greater than equals. When we are checking for greater than equals, we are checking that if the number is greater than or it is equal, but neither satisfies the condition, so it will be false again. After that, we have less than. So num1 less than num2. Yes, this time it will result to true. After that, we have less than and equals. Less than and equals also check that whether num1 is less than or it is equal to. So it checks the condition that it is less than num2. So it will also result in true. After that, we want to see equals. Now this equals num1 double equals num2. This would also result into false. Why? Because 15 is not equals to 18. That's why it will result to false. And then finally, what we will check here is for num1 not equals num2. Now this will result into true. Why? Because num1 is 15 and num2 is 18, and the relation we are using here is not equals. So 15 not equals to 18? Yes, it's true. So this statement will return true on the screen. So let's see everything in action. So we compile this first and then we see the result. Now, as I have mentioned, the first one is num1 greater than num2. It results into false. Then 15 is greater than or equal to 18. It results to false. Then 15 is less than 18. Yes, it's true. The result is true. Then 15 is less than or equals 18. Yes, the result is true because one of the condition is satisfied. Then we checked for 15 is equals to 18. No, it is not true. So it results into false. And finally we checked that is 15 not equal to 18, and the result, yes, it's true. So that's how relational operator works in a Java program. I hope that is very much clear now. So the next thing I want to focus here is logical operators. Now logical operators are namely and, then we have or, and we have not. Now what is this logical operators? Now logical operators is used to combine multiple relational combinations together. Let's see that in action, and I hope that will be very much clear to you now. Okay, again we'll use our same convention of mentioning two variables, namely num1 is 15, okay, 15, and another variable num2 equals 18. Now after that we want to check. How can we check? Let's see, using logical operators. System.out.println, and we want to check is num1 greater than num2, and also we want to check for num1 less than num2. Now what is and? When we use and in between two relational expressions, we are specifying that both these conditions need to be true to get the entire result to be true. Now here, num1 is num1 greater than num2? This is false. Fine. And num1 is less than, okay, so this is num1. Okay, typo error. So is num1 less than num2? Yes, this is true. But this condition has already become false, and in an AND logical expression, if one of the condition is false, then automatically the entire expression evaluates to false. So the entire result will be false for this line. Now you may be asking that why is it so? Why can't we consider a single result? We can. This is why OR operator existed. So to use OR expression, we'll write something like this. We'll simply remove this and we'll use OR. So we use OR using two pipe symbols, and this is num1 greater than num2. 15 is greater than 18? No, it is false. This first expression is false. So till now this expression is evaluating to false. Now it encounters OR. After that, is 15 less than 18? Yes, it's true. So finally it has got true. So in all expression, in all logical expressions, if one of the expression, if one of the condition is true, then the entire thing results into true. Okay, so the next thing we will be focusing here will be not. Not logical expression reverts the result into the opposite one. Reverts the result only means if it is true, it will revert it to false, and if it is false, it will revert to true. Now let's see that in action as well. So we want to find the result of int that num1 less than num2. Normally this is a true condition, right? Num1 less than num2. Now we want to revert this. That's why we use this not symbol, and not is used as an exclamation symbol. Let's see all that in action. So we compile this, no error, very fine, and we see the result. Now let's see. The first one, as I told, that the first condition is only false. That's why the entire thing results to false, since we are using AND. Secondly, we were using OR. In OR, if one of the condition is true, the result is true. The first condition was false, the second condition was true. So that's why the entire statement evaluated to true. And the last one, as I've already mentioned, that not operator reverts the result. Is num1 less than num2 is true, and that's why we are using not before it, so it reverts that true to false, and we get the result false on the screen. And I hope that also makes real sense. So by that we complete unary operator, arithmetical operator, relational operators, and logical operators in Java. And trust me, these are the building blocks of a Java program. Whenever programs we write, whatever programs we write, we have to encounter these statements. And believe me, 99.9% of Java programs uses arithmetical, relational, logical, and unary operator. So you are just becoming familiar with this, and you are getting powerful with Java, and you are in a process of moving forward to write Java programs in very soon. Keep the trust high, and we will be in a situation where you will be the boss in Java. Thing that I want to mention here is a ternary operator. The ternary operator is a conditional operator. Now let's see that in action. Let's see how ternary operator looks like. So suppose we are declaring a variable boolean because we want to store true or false value. So we use a variable result, and this is how we write. First we write the condition inside a parenthesis. So the condition, my condition will be num1 is greater than num2. Is it true? Now we finish the condition with a question mark. So it asks, is num1 greater than num2? No, false. If it would have been true, then the first part will be executed. And if it is false, then the next part will be executed. And we finish it with a semicolon. This is how the syntax of a ternary expression looks like. So for this result, it will evaluate to false, and if false means the second part will be executed. So false will be stored to result. And if we print out result on the screen, so to print out we use again system.out.println result. Save this, and we compile with javactest.java. No error, very fine. Now see false. So this false was stored to result as the condition evaluated to false. So that ends ternary operator, and I hope that is also very much clear. Ternary operators comes very useful whenever you are working with some complicated relations, and in that method you can simply reduce the complexity of your Java program by simply writing a single line using multiple lines using if-else block. We will be covering if-else block, but always if-else block is a robust method. But simply when we need to compare between two expressions or three expressions and a single line, or we want to store the value of that resulting expression to a particular variable, so in these cases ternary operators really come helpful. So I hope ternary operators are really getting into your mind. So that being said, I'll keep this video to here. So in that way we covered the fundamental and the building blocks of a Java program, which are the operators and the operands. And I hope you liked the video as well, and you also got to know exactly what I taught you. If you are still stuck at some point of time, do rewind back and forth at your own pace, and I will be always there waiting for you. Till then, I will catch you up in the next part. It's time to sign off. Take care, spread love, and enjoy coding. And if you do find this video useful and learnt what I shared, do like this video, and then if you find me interesting and this channel interesting and sort your needs, don't forget to subscribe CodeBuddy, as here I will be putting up courses and series on programming languages like Python, Java, and also trending technologies, and teach you many applications under web and software development. And if you want your friends also to learn this part and to be a part of this mega series, then do share as well. Express your emotions in the comment section because your support means a lot. Thanks, and stay connected to CodeBuddy.